Yeah, it's
Yeah. So these are your raw abundance data, and this is your species abundance distribution right here. It just tells you the relative abundance as a proportion of total population, each of those. So this is your species abundance distribution. It's hard to tell what your community looks like by just looking at a page full of numbers. But we can make a graph. A nice graph.
a rad graph. Don't be sad. So sorry.
What would be a reasonable way to rank your species? If this is what you know about them,
Yeah.
what's a reasonable way to rank them?
Greatest to least.
Yeah, most actually least abundant.
Jeez.
Don't be so surprised.
I'm gonna drop by. Such a shame.
Why don't you drop by? You just told him what he wanted to know.
Yeah, I'm a business major. Because I have a C in all my other bio-related classes.
Oh, actually, that's not usually how I draw it.
Yeah, because then you have to be a community on that.
I did as a major. I said I passed this semester, and I would like to do it well. Like, so let's see what I do.
So that's all you do with the species abundance distribution.
Oh.
Now, one of the reasons that it's good to make a rank abundance diagram, make the rad out of that, is because you can compare communities easily and quickly. Remember how we talked about using the 900 intervals to quickly determine if one is the difference or not? When you have a rank abundance distribution like this, you might have another community with a different species abundance distribution. You can plot it on the same graph.
Alright, so quick question.
Yeah.
What do those lines represent? I guess I'm not understanding.
Don't worry about the lines yet. Worry about the points first.
Okay.
What determines the position of this point? Rank species 1,
Oh, okay.
abundance 0.5. Where did that come from?
Yeah.
Yeah, it was the most abundant. It was, just like you said, highest to most to least. So if we have this black community that I've put up here, and we have this pink community that I've put here, if you had just been looking at a bunch of numbers next to each other, it might be hard to know which one is more diverse, or which is more rich, or which is more even, or one's more skewed to be a highly dominant community. Whether you're looking at this diagram or this diagram, how easy is it to tell which community has a higher dominance score and which community has a higher evenness score?
Okay.
Based on how.
Yeah, so let's start with the black and red. Which community looks like would have a higher evenness score? And which one's going to have a higher dominance score? Yeah.
Okay. That makes sense.
Now, you ordered the species from most abundant to least abundant. If you just add up how many species there are, what's that a measure of?
Richness.
Richness.
Oh.
Which one is richer?
Red.
Which room is richer over there?
They're the same.
They're the same.
Dude. No, I came in here not knowing any of this. So bad. The last time I went to the test thinking I was going to be good, I got 63.
Don't be advertising your grades to other people.
Sorry.
Figure out a graphical way of thinking about it that helps you understand the concept. Dr. Judd gave you this graphical way of thinking about it in class. The reason that we gave you that graphical way of thinking about it is because that's an easier way of thinking about it than just stuffing a bunch of definitions into your head. Use the graph to help you remember what the definition is, rather than using the definition to then allow you to draw a graph. Might be a more efficient way of learning it.
Which of those two would you give a higher diversity score to? Of the two on the right.
I drew the more obvious difference.
Yeah. Jamie, do you have what's your intuition telling you about how higher diversity, so Shannon's H value maybe?
What are the two components that go into this?
Yeah, that's exactly the next thing I was going to ask. Because these two voted, I wanted to see what his intuition was, and I wanted to unpack your intuition. It's actually functioning just fine in all of your brains right now.
So did you guys both say that?
Yeah.
What do you think, Jim?
I don't know.
Be bold, Jim. What's the first thing that bubbles up to your brain? What's your gut instinct tell you?
Black because it's more, I don't know, spread out. Like there's a higher and then a lower. It's more extreme.
Okay, so it's not the black, it's the red. Oftentimes the thing that bubbles up, oftentimes when you're on a test, the thing that bubbles up to the top first is the right answer because that's the one you actually studied, so it's the one that is at the top of your brain. In this case, it happened not to be, but that's fine too. Let's do what Dr. Judd is advocating. Let's unpack why it's red rather than black. What are the two components of diversity?
So I don't really know. This is why I thought. So like a diverse school, right? It's a bunch of different like ethnicities at like a high rate. Like everyone's kind of like there's a bunch of different ones kind of the same. And the black line, it was a huge difference. So that would be like all white schools. There's like very few minorities. But like going in the middle, it's like a very good diverse school. That's why the diversity
So
is high.
you're thinking about evenness right now.
Oh.
You're thinking very clearly about evenness, which is in fact what we were just talking about, one of the components. But there's another thing that goes into diversity. What else would go into diversity besides evenness? Say it louder, Clara. Look at the Shannon's H equation. I'm not going to make you memorize it, but you should see both number of species and their abundance going into that. He's using your example. Beautiful.
That's it is fine. Right? Even when I'm wrong, I'm right. Like I said. Because
Well, we're trying to show you that, like, yeah, studying for tests and taking tests is challenging, but you have knowledge and understanding underlying all this. So there's stress in front of the test, and there's accessing the knowledge you have, and when you can do those two things.
So racial diversity at university is not really that different. It's a very close analog to species diversity in a prairie. So think about things that you know. You know Williamsville College. Do you think of Williamsville College as a terribly diverse place? No. It's got a bunch of white people, and it's got very few people of other ethnicities. This is Williamsville College. A lot of white people, not very many other people. University of Texas at Arlington, where I was a PhD student, it's socked right in the middle of a major metropolitan area. There's a highway that cuts the campus in two, literally. There's bridges over this pretty major road, and you have to go over these bridges to get from one part of the campus to the other part of the campus. It's in a part of town where there's a heavy Asian community. It's a really diverse school, but it's diverse not because it necessarily has more different ethnicities. It's diverse because what's different about it compared to Williamsville College? Not to strike too close to home. Okay, so diversity includes evenness in it. What else does it include? It also includes richness. So what I haven't done here is I haven't added American Indians, Indian people from the Indian subcontinent. I haven't added in Pacific Islanders. I haven't added in all of these other groups that we also don't see at Williamsville College necessarily. So University of Texas at Arlington is much more diverse than Williamsville College is because it not only has higher species richness, more ethnic groups present, but also those ethnic groups are distributed more evenly in terms of the number of people that are at
That's
those
so
schools.
is diversity have to do with like evenness that it's spread out
And
and
richness.
So what happens if like say one's more rich but has less?
That's how we use these metrics that we use in class. Shannon's H, Simpson's E, so they use J. And
So-
we're working on it because when you have this visual comparison, you can get certain situations where it's hard to make distinction, exactly what you just described. In that case, these metrics become useful.
So which of these is more species rich?
But
This one has higher richness. Which one has higher evenness? This one has higher dominance. At this point, I would have to do the math to figure out which one is more diverse, because they're both different enough in richness that I can't just intuitively tell, and they're also different enough in evenness that I can't just intuitively tell. I would actually have to calculate the diversity index to figure that out. And that's why the index is there. It helps you when it's not as clear. This one has more species and more evenness. Well, that's the one that is the most diverse. But in places where it's more ambiguous, you need an equation to help you actually put an aggregate number on it. So,
And also it can be useful to have an index when there's lots of different comparisons.
you were late for
I
something?
want me at 4.
Now you get to run.
Yeah, no, it's school. Oh,
What other questions do you have?
All right, guys.
Just say you prioritize your
Oh,
Do you have a team
so,
meeting or something?
yeah, it's over half. This is the last meeting of the year. I'm so ready.
Well, you don't have a game this weekend, do you?
Hey, Doc, no. Yeah.
Well, why do you need to have a meeting?
Because I don't know. See you guys.
Okay, well, that makes sense. Other questions? You guys done? You guys all tapped out?
I have a question about number 19 with the analyzing the graphs and trying to determine which continental climate is like constant.
Oh, that's Dr. Judd right there.
So when we're trying to identify,
I actually taught this semester, and I didn't actually use those. I didn't actually concentrate much on those graphs,
Okay, cool.
so I won't be making a question about those graphs.
okay.
This is the bad thing about looking at old exams. Dr. Judd typically has taught that portion of the class in the past. I taught it for whatever reason this semester, and those are graphs that I don't concentrate a lot on when I think about this. What I think about mostly is a model of the world and how the world works. So I would be more likely to ask that type of question by giving you an image of the globe and ask you to, based on what you know of solar inputs into the Earth, how that affects air circulation, et cetera, what kinds of climates would you expect in particular places? And so my way of questioning you on that would be very different. So remember in that introduction to Kanza when we were talking about global air masses, how that carries moisture, where moisture falls, where moisture doesn't fall, where you have cold descending air versus warm rising air. Warm air carries more water, cold air holds less water, et cetera, et cetera. All that is all wrapped up in there. Now it ultimately results in those graphs. But I tend to work from how does the world work to cause those graphs than to look at the graphs and say, okay, where in the world does this graph come from? You can figure them out from both directions. It's just a difference in kind of approach. So I wouldn't worry about question 19 because I showed you one little graph that showed you water deficits, but once again, I think I spent a minute on it. So yeah, don't worry about that.
So,
If I was teaching photosynthesis, I probably wouldn't have told you anything about the light reactions also, because we just have different approaches to things, and we're different people. We think about science slightly different. It's not that the light reactions aren't important. They're just, for me, less important than carbon fixation in terms of why we have C3 and C4 plants. All plants do light reactions in exactly the same way. Not all plants do carbon capture in exactly the same way. So we're different people. So. And also, I spend a lot of time talking about photosynthesis to 9 science majors, and if I gave them the light reactions, it might not go so well. So that's the other thing I have. Well, I teach the class the same semester, and so I think about photosynthesis. I can think about it with think about the light reactions, stuff like that. But
It's kind of funny because he's teaching another class that's CGI, that's where he has to do photosynthesis. I'm also teaching another class right now where I teach about photosynthesis. It's a 300-level biology class.
they're taught in different ways in all 3 classes. So, yeah.
So like if someone were to try to, like, let's say you have a student in both classes, would you still accept like the same answer despite being taught different methods?
Which is different levels of depth and detail.
And that's where you probably ask slightly different questions.
And ask the questions in different ways. If there was a junior level student who got in because they transferred in was off sequence, and the junior level student was open plant bio in this class, they might answer the question that we would ask them about photosynthesis in a much more complete and detailed way. That wouldn't get them more points, as long as they covered the points that we wanted you to hit in the question that we asked in this class. So,
And so like for that cycle question, we would want us to answer with responding with what enzymes and what specific things are happening in that section like we just went through, or
You know, in the Calvin cycle?
yeah.
Yeah.
Okay, good.
yeah, but if you took a cell biology class where they really delve into the molecular biology of photosynthesis, you're going to learn the Calvin cycle in a way that you don't want anything to do with. You'll have to learn the structure of all of the molecules, et cetera, and it's a hairy mess in there. And we gloss over all of that because, once again, you don't need to know that to understand what the fundamental differences are between C3 and C4 plants and why we see more C4 plants in concentrated and we see C3 plants in concentrated. So we kind of pre-filter the information for you because we're hoping that you get to understand how concentrated works. We're not concerned about the molecular details of photosynthesis.
In plant biology, we do some comparisons between C3 and C4 plants without making such a strong dichotomy because there are intermediates called C2 plants that use that 2PG molecule. And then we talk about how they do that. But we don't need to get into that gray area here because we want to understand C3 and C4 plants.
Yeah, we mentioned CAM plants just briefly. We talked about, it was the day that Dr. Judd was late and I finished up his slides, rather than a spatial separation between light reactions and the carbon fixation reactions, it's a temporal divide. But once again, we don't go into any detail beyond that because those are plants that generally occur in deserts rather than at Kanza. You can
one CAM Kanza plant or something like that.
There's one species of prickly pear that lives at Kanza. You can't even find much of it. You run into it occasionally, and so we don't worry about it because it's just not important enough to think about it. the older you get, the further you get along in the program, the more complicated things will get, and the more we will concentrate on nuance rather than strict dichotomies. Simply because you will become better equipped to do that as you get more knowledge and more experience. Other questions? Seventy-two, looks like they're ready to meet.
Alright.
Okay, alright. I mean, if you have a question, we'll be happy to answer it.
No, I've been scrolling through trying to think of a question.
Then we will see you guys tomorrow. Oh, I should save this, shouldn't I?